Goes here and there to Joe. So it's movie day. We're picking up where we left off, talking about matter. And I'll go ahead and draw it up here on the board. The way we classify matter, so we're all on the same page. Matter can be a pure substance or mixture. And what are the two options if it's a pure substance? You guys just did, you guys have homework to hand in. Go ahead and get your homework out too. So what, and you guys did homework on this question, what are the two options if it's a pure substance?
Elementary compound.
Yep, elementary compound. You got it. CPD for compound. And then if it's a mixture, what are the two options there?
Homogeneous and heterogeneous.
You got it, homogeneous and heterogeneous. Homo, heterogeneous. Hey, I'm picking up homework. The way homework goes is it's due like by 3 p.m., but today I'm going to have to boogie out at 1. Usually I'm here until 3. Hi. So if you just go ahead and stick it under my door by 3, that would be awesome. I'm up here. So the good thing is you have a little bit of time after the class to kind of get your homework in. Thank you. And Jared was making the comment that, like, under my solutions, there's more solutions than what problems I assign. So don't think, oh my goodness, I have to do all of these. No, it's just I have, in some cases, more solutions than you. All right. Okay, so we're going to talk a little bit about properties today. When I think about properties, it's kind of like if you play the I'm Thinking of game, and you guys know what's in your way. Or say, for instance, playing an I'm Thinking of game, and I think of something, and you guys got to ask questions, like the 21 questions. Okay, we do it all the time on long trips when our kids were young. We did it when our kids were little. And you ask properties about the object I have in my mind. Okay, just questions. So that's property. Okay? What's a property? Well, it's a characteristic of an object that you can sometimes quantify. So it has a number associated with it. Sometimes it's just is it yellow? Bigger than a bread box. Yellow would be property. Okay? So as it turns out, and this is more not just chemistry, this is more like physical science. In science, the properties that we associate with matter, I call them kind of yin and yang, okay? These two slides go together. The property could be intensive. And when I think of intensive, I think of independent. So an intensive property is independent of amount. Independent. I can almost see that. Let's see if yep. Independent. I can't spell. Of amount, A-M-T. Okay, so in. You know, things like would be, these are all intensive properties. I don't care how much I have, it's a color, okay? Whether I have 1 pencil or 144 pencils for the yellow. What temperature does ice transition from solid to liquid? So that melting point temperature and the freezing point temperature are the same. So that would be 32 Fahrenheit. You know, it's independent of amount. It could be like a bucket full of water, or it could be like a thimble full of water. Is it going to combust? What are its reacting conditions? It doesn't matter whether I have a pinch or a lot. It's independent of amount. Will it conduct electricity or thermal energy? Okay, so yin and yang. Yin might be intensive properties, and yang would be extensive. So if intensive properties are independent of amount, then guess what? Extensive properties depend on amount. So it does depend on how much you have. And if I'm doing the I'm Thinking of game, that's not fair if you're the person who's thinking the object to think. It's not just one slice of bread, it's 10 slices of bread. Okay? So what does depend upon amount? Well, mass depends upon the amount that you've set aside. Volume depends upon the amount of matter you set aside. Number of moles, actually, some of you may know or may not know, moles is just kind of like moles is as a parcel of atoms or molecules. A mole is actually 6.022 times 10 to the 23rd of those things. So that's amount. How much heat is going to be given off during combustion? So you're like, if we were thinking of the what if game, this would be a really good question. We'd be really geeking out on it. If I was thinking of paper, and you said, you said, is the thermal energy given off when it burns less than this, or greater than this, or something? Well, it depends on how much paper you're burning, okay? If I'm burning one piece of paper, I can go ahead and isolate, see how much energy is given off, how toasty that area is. Versus if I'm burning 20 pieces of paper with sufficient amount of oxygen for it to combine. Okay, that's going to give up a lot of energy. So, the amount of energy given off during combustion. So it just depends. Okay, so intensive, extensive. Intensive, independent amount, extensive, does depend upon it. Okay, so that's yin and yang, and then you've got to clear your palate. Okay, take some. Have you ever heard like to give you sorbet between if you're eating something you want to clear your palate? I don't know. So clear your palate. I have another pair of properties, and there's some overlap between these pairs. So if you're like, there's overlap, you're totally right. So I have physical properties versus in a minute chemical properties. A physical property is one where you can gauge how it is just by non-destructively gauging. So things that we could gauge without destroying the object or the piece of matter. What color is it? What size is it? Right away, color and size, you're like, dang, color was intensive and size is extensive, you're right. But they're both things that I can gauge. Might need to kind of put the object on a scale to get mass or something. Temperature, non-destructive. Density, non-destructive. Whenever you take, and I'll try to kind of convince you of this, if you need convincing, but if I was to have water here, and I was going to go ahead and put it on a burner, and water, it's funny when we say water, you're like, oh, I know it's liquid. Water is a liquid solid gas. But I was going to take this liquid water, and I'm going to heat it up. I get those cute little liquid water molecules going fast enough and slip their bonds with each other, and they go from a liquid to being gas. Okay? Honestly, that sort of property of making that change its phase from a liquid to a gas, that didn't hurt any. That was non-destructive. The cute little water molecules still the same thing. So the boiling point temperature, the heat of vaporization is related to the boiling point temperature. The heat of vaporization is just how much energy do I need to pump it with in order to get it to vaporize. What is vaporized? The liquid to gas. Okay, so no harm done to the cute little molecules doing so. These are all examples of no harm done in measuring them. So if a property is non-destructive to measure that property, then it's a physical property, okay? These last, here's one for you. It's kind of a quick and dirty sort of thing. If you read, I'll let you kind of absorb what the figure says, but if you read the figure, we have two white powders, okay, at room temperature. They're solid white powders. And one will make you sick, naphthalene, and one will cure your head from hurting. Aspirin. A quick and dirty physical property would be what temperature does it melt at. And we're fortunate that actually, if I have boiling water, what temperature is the boiling water? What temperature is the boiling water? You can give it Fahrenheit, Celsius. What temperature is boiling water?
100 degrees.
It is 100 degrees. 100 degrees Celsius, 212 Fahrenheit. I guess it's my bad because the teacher, I know that, but yes. So water boils at 100 Celsius, 212 Fahrenheit. So the point here in the caption is like, okay, what's going to make you sick will melt at 80, and what's going to cure your headache is going to melt at 135. So this is kind of convenient. We put them both at a temperature of 100, and one melts and one doesn't. So take this one and go ahead and again, when this one melts, naphthalene, cute little naphthalene particles, molecules. Okay? They're nothing, it's non-destructive. All we're doing when it melts is we're breaking those, most, or a large part, we're breaking those intermolecular bonds that we talked about before. Okay, color, it's a property. Don't need to do any sort of destructive test to gauge the property. So, would you say, do you remember, so is color intensive or extensive? Is color dependent upon amount, or excuse me, is not dependent upon amount, intensive, or is it extensive? How many people think color is an intensive property? Okay, now I have a few videos. I hope I got my videos lined up. I tried to. So if physical properties are measured with no harm, chemical properties are measured with destruction. Chemical properties, honestly, if you send a sample for analysis to a lab, say it's an environmental sample, and you want a whole series of tests to be done, they're going to do their physical property tests first, okay? And then they're going to leave their chemical properties, chemical tests at the end because they're destructive. You will not have the same stuff, okay? We'll talk, I have some videos to try to kind of show you chemical reactions. So you must have a chemical reaction in order to assess it. You know a chemical reaction has occurred if what you started out with is altered, changed. Okay, if you get something new, you know you had a chemical reaction happen. So here are some examples of chemical properties. You take a chunk of matter, you're like, well, will that chunk of matter react with water? Not just dissolve in water, react with water. We were talking about sodium and potassium, lithium, rubidium. Those guys, they react in water, with water, to create hydrogen gas and I can't remember what else. It must be well, anyway, I think they turn into their ionic form. But it's destroyed. You start out with a chunk of sodium metal and it reacts with water. You don't have sodium metal anymore. You have sodium of sorts because what's there cannot be treated or cannot be destroyed. Okay, but it's not the Na sodium metal. If you burn something, guess what? I mean, it can be an important property. Materials testing, you need to know if something will burn, and if it burns, how much energy it gives off. You need to know it, but don't count on having your matter back or having your matter the same way. Something breaks down, decomposition maybe breaks down. That's a chemical property of that matter. Does it break down or doesn't it break down? It's kind of a pass-fail sort of test. So here are some, see if you can see how new substances are formed. Sometimes it's harder than others. Have the answers to these in your books? No. So we can go right there. Okay. So what about the first one? Color. Is it chemical or physical property?
Physical.
It is physical. Ding, ding, ding. Okay, Jared, what about the next one?
Chemical.
Chemical. Ding, ding, ding. They have a picture coming up to show that regular iron is all Fe and rust is FeO. Iron oxide. A form of iron. Okay, we'll go to you, RJ. Okay. Dynamite can explode. What? Chemical. Yep. It's like kind of like Humpty Dumpty. Can you put it back together? No. Okay, so. Okay, Gabe, what about density?
Physical.
Physical, very good. We'll be talking more about density. Density is kind of how fluffy something is, or how dense something, or how compact it is. And all we got to do is get a mass and a volume and do a little math division and knock it out. What's your first name?
Cold.
Cold. That's cold. So what do you think about aluminum melting at a particular temperature?
Physical.
It is physical, exactly. No aluminum atoms were harmed in the breaking of these bonds. You want to get your solid back again, you just let it cool down. So back up to you to Quinn. What about, again, color?
Physical.
Physical, yeah. And you know, you won't have these, but these will be on your homework, and I can already let you know that on your Unit 1 exam, you're going to have a section, and you're going to have to do exactly what's in the slide. For your unit exams, what I will have done past, I'll do here, is to give you like an outline of what your test is going to be like, so you know what you're going to question in general. How cool is that, right? Okay. So these will be due on Monday. Is this the second set? First set? Okay, this is the first one we got to today. Get my classes mixed up. Remember, I'm doing 3 classes back to back here. These will be due on Monday. This is just to kind of remind you where we're at with regard to classifying matter as either pure substance. You've got 2 options over here. It's got to have the same repeating unit, whether it's all the same atom, we call it an element, or if it's molecules or formula units, some sort of compound, which you do the formula for, then we call that a compound. And then over here we have 2 types of mixtures. We have it well mixed, homogeneous, and we have it chunky, heterogeneous. So I'm gonna kind of piggyback, dovetail, whatever you want to say, on the whole physical property and chemical property, and I'm gonna say physical change and chemical change. They go hand in hand. Physical properties are measured without changing the substance. Physical properties are non-destructive. A physical change is also non-destructive. I hope you can kind of read that in this wording. Physical change, no new substances are formed. It might be in different form. They may look different. Okay. So, for instance, we talked about the changing the physical phase, you know, liquid, solid, gas, and we're going to be talking about these words coming up. But here's another one. If you like physically chop it up, or you grind it, or crush it, count on at the small level, the molecular level, the atomic level, nothing's changed. Okay, so think of it that way. Non-destructive seems destructive, and actually just seems destructive. If you're after particle size, then you know, you're sample, you're doing particle size test. You know, this would be destructive with regard to that. I already mentioned that if you take sugar and you put it into water, the sugar and the water remain unchanged. They're just kind of commingling there. But on the video we saw with sodium metal, you put that into water, and the sodium is no longer sodium in that sense, where it's just like sodium atoms. So that kind of depends. So I have a few slides kind of dealing with phase changes. So these are the 3 physical phases that we're going to deal with. What's another phase of matter on the sun? First letter P. Plasma. Sometimes I'll have students, and rightfully so, sort of, they'll come in and like, what about plasma? It's kind of got its own little sort of thing going for it. But we're just dealing with solids, liquids, and gases. And we spent some time talking about how, like, the solids are rigid, and so they don't take on the shape nor the volume. Liquids have some flexibility. They'll take on the shape, but they'll keep its own volume. We said gases are all over the place. We also said with regard to solids, they have a high degree of intermolecular bonding. And with regard to kinetic energy, all matter has motion, and that's the motion when we talk about kinetic energy going on. But it's more of a filling all those boxes again? It's more of a vibrational motion than a translational motion. Liquids have some degree of intermolecular bonding. Kinetic energy, intermediate. This was Goldilocks. This would be Goldilocks. Gases have basically no connections with each other, no bondings, intermolecular bondings. And the amount of kinetic energy is high. So on the unit 1 exam, I like to throw something in there about question along these lines too. So as we're going to talk about changing from solid to a liquid or liquid to a gas or gas to a liquid or liquid to a solid, and I really think that this middle column, that if you think of how it's bonded to each other, that's going to kind of help. Or just everyday experiences. So make sure we're all on the same page here. When I talk about intermolecular forces, I'm talking about the forces between the repeating units, whether they're ions or molecules. Okay. So here we go. These are labeled from left to right, solid, liquid, gas. Okay, most kinetic energy, least kinetic energy. As we go, if I were to take ice cube, you say if I need to melt it, I'm going to heat it up. If I now have it melted, liquid water, if I wanted to go in a vapor, you'd say heat it up. In doing so, as we're adding heat going from left to right, we're breaking those intermolecular bonds. Okay, the bonds between the water molecules. But what we're not breaking is are the chemical bonds, the bonds that are connecting the oxygen and the hydrogens. So as we go from left to right, as I have them listed, if we have something that, and actually I have a slide coming up, is as water vapor condenses, okay, bonds are formed. As liquid water freezes, bonds are formed. So here's those two terms that I mentioned, or one term that I mentioned. I mentioned this one up here. Exothermic, yeah. Something gives off energy. So here we go. This one is exothermic. And sometimes it's hard to picture when I go from a gas to a liquid, how am I giving off energy? Or if I go from a liquid to a solid, how am I giving off energy? And I don't know if I can convince you in the next 10 seconds or so. But you are giving off energy.
Then when water turns to ice, it's giving off the heat, it's getting rid of it.
Yeah, it is getting off the getting rid of it. Yes, exactly. In weather, when we study weather, one of the things we know about clouds is that a cloud is water that has come together and gone from a gas to a liquid. That's what a cloud is, unless it's cold enough, and it might not get from gas to solid or from liquid to solid. A gas to a liquid within a cloud, and then clouds actually have a lot of thermal energy, and from that condensation energy is released, a lot of it. And that's kind of the crux of some of our crazy summer thunderstorms and hurricanes and such. So yeah, energy is given off. Now we probably got this one. So this is endo. Endo, think in. And most people buy this one, endothermic, and it kind of goes back to, if I have an ice cube, how am I going to get into liquid? Endo, I'm going to put energy. What's that energy going to do? It's going to break some of those intermolecular bonds. Leave a few of them, because it's not going to totally gasify it. Okay, so endothermic versus exothermic. Okay. And this is, I think I have this slide twice. It's almost like it needs some sort of rap music to go with it or something. It takes energy to break bonds, and when bonds are formed, energy is released. I didn't say it right, but it summarizes kind of the previous slide. It takes energy to break bonds, no duh, right? But what's less intuitive maybe is when bonds are formed, energy is released. Okay. So, do you guys have these words here? Okay, good. You guys would all tell me that this is melting, and you're totally right. Liquid goes to a gas, that's evaporation or vaporization. And These would be, you seem like endothermic to you? Yeah, energy's put in. Now, liquid to a solid, bonds are formed, so exothermic, we call that freezing. And a gas to a liquid, bonds are formed, also exothermic, we would call that condensation. So top ones are endothermic, and bottom ones are exothermic. And you might think, well, that's all the phase changes possible. But there's one other option, and that is to skip the liquid state. And it happens more than you might think. Okay, but before I do that, here is a little video. Think of this cute liquid would be kind of the left and right, breaking the bonds. So examples are melting, evaporating, sublimation if it's the solid to a gas. So exo energy out, okay, would be ones where bonds are formed, and that would be bonds are formed when you go from a liquid to a solid, as in freezing, when you go from a gas to a liquid, as in condensation, and then I prefer, I'll put it up here, I prefer that last one, deposition. My favorite word. Deposition, because I like depositing. What's it depositing? In the case of frost, it's depositing water vapor into water solid. All right. So this is the one where you use it takes energy to break bonds, and when bonds are formed, energy is released. I think that's a good place to stop. But yeah, we'll pick up with chemical change. I'm running out of energy, people. So we'll pick up with chemical change and do videos. And so on Monday we'll start the next part. On the next part, not the next part. Yes. Did we skip around?
Yeah, we didn't have the solutions part. Yeah.
Oh. Okay. Let's see. Is that a whole part or just a? Oh, we didn't do that from yesterday, from the other day. Thank you. Okay, we'll pick that up too. Definitely. Have a good weekend. Don't forget to look at the moon. And it's a super moon too, which just means the distance between the moon and the earth varies, and it's a close moon. So that doesn't always. So super moon, eclipse moon.
Hopefully it's clear out.
Yeah, hopefully it's clear. Right.
Which one was the one that was due today?
The one that was due today, I've got some up here. It looks like 3-1, 3-3, 3-4, 3-7, and then 3-31, 32. So 1, 3, 4, 7, 3, 1, 32. Be safe out there.
You said you're going to be in your office till one?
I'll be in my office till, well, I have a class coming up, so, and it goes till 1, and then I'm going to actually kind of head out the door. So you can still slip it under the door anytime you go through your stuff.
To the office? Or?
My office is at 5:08.
Thank you. What's the definition of property?
It's a characteristic. I probably didn't pause enough on that slide.